This is just a brief overview of simplifying radicals when you have a negative radicand. The number underneath the radical is what we call the radicand. And up until now, we've kind of said, well, we can't do this. What you get if you were to type this into your calculator would say an error, the square root of -5. So that's a problem. We have to find a way to get around that. It doesn't mean that we can't solve it. We just have to come up with something different. So let's think about, why can't we square root a negative? What is a square root doing? It's saying that some number times itself has to equal the number that's under the square root. So for example, we know that the square root of 9 is 3 because 3 times itself is equal to 9. It could also be -3 based on what we're talking about, because -3 times -3 is also 9. But notice, anything times itself, a positive times a positive gives me +9, or a negative times a negative also gives me +9. So how could I possibly get something to equal the square root of -9? That's the big question here. And the answer is that we can't. It's not possible. There are no two numbers times themselves that are going to give us a -9. And so that makes this kind of a tricky question to answer. So what mathematicians did hundreds of years ago, when they stumbled across these kinds of numbers, they needed like a quick fix to be able to get through these problems. And so what they did was they made up a number. They just invented one. They figured, let's create this number so we can maybe use it to solve some problems, and then we'll figure out how to get rid of it later. And so what they came up with was this number called I. And I is an imaginary number. Now you're like, okay, you just lost me. Imaginary numbers. That's what it is. I is called the imaginary unit because it's the smallest type of imaginary number that we have. It's the imaginary unit, like 1 would be a unit for a real number because it's just the smallest, but it's I, and what I stands for is the square root of -1. Notice it doesn't tell us what the square root of -1 is equal to. It's basically just a placeholder. We're going to use this I to represent the square root of -1, and that allows us to rewrite things so that I don't have those negatives under the radicand anymore. So if we look at this property up here, the property says that for the square root of any negative number, if I have the square root of -r, that's equal to I times the square root of +r. Now, how did we get that? Well, it's the same idea as breaking down and simplifying radicals like we've done before. If I have the square root of -r, I can rewrite that as the square root of -1 times r. Well, this -1 is what we're going to say, well, the square root of -1, we're going to call that I, and that's why it gets to come out in front and the r stays left over inside. I don't want you to get stressed out about thinking about what is the square root of -1. It's not possible, but we're going to use I instead to stand for it. And after we finish all this stuff on quadratics, we're going to really look at these imaginary numbers in detail, and you'll kind of see what I mean. We can set up problems so that even though we're using I and we don't know what it stands for, it ends up canceling out in the end anyways, and what it did in mathematics was it allowed people to start solving problems that otherwise have gone for hundreds of years with no solutions, all because someone just decided to invent a number. So here's a few examples of simplifying using this idea of an I. And we're going to simplify these radicals just like any other. Okay? So I'm looking for the biggest perfect square. Now remember that our perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. So let's just list these out so we have something to look at. We'll go up to 100, 9 squared, 10 squared. We are looking for the biggest perfect square that goes into 50. Make sure you're not working from the top of the list down, because that's what several of you are doing. And so you're finding numbers that work, but they're not the biggest. You need to start from the higher end of the list and work backwards towards the smaller numbers. So what I get here is that I break this down actually into 3 parts. I have negative 1 times 25 times 2. 25 is my perfect square, 2 is not. Now remember, anything that we can take out of our square root, we do. The square root of 25 is 5, but we also know now that the square root of negative 1, we can write that as I. So we would take that out and we would get 2, the square root of 2. So 5i times the square root of 2 is what we get. What you'll start to notice, okay, if all I said was square root of 50, you would have simplified that to be 5 times the square root of 2. The only difference when you have a negative is that whatever you take out in front now has an I on it. Okay, and that's it. If I said something as simple as what is the square root of negative 4? Well, I can do the square root of 4. It's 2, but since it's negative, I get 2i. If I gave you the square root of negative 3, I can't do that, but I can get rid of the negative. It would be I root 3. So that's kind of how we work with these. I'll do one more example here. Let's say that I have the square root of negative 243. Again, go back to your list. I'm looking for the biggest number that goes into that, and it just so happens that it's 81. And guys, there's no quick way to figure this out other than guessing and checking. You need to sit with your calculator and test all the numbers. Try to divide them and see if they come out evenly. So this is negative 1 times the square root of 81 times the square root of 3. Remember when we go through this can come out, that gives me the I. This can come out, that gives me 9 when I square root it. But the 3 is not a perfect square, so it has to stay under the radical. 9i times the square root of 3 is what we would get. Okay? How would we use this to solve a problem? The exact same way we would solve any other problem, but now we just have one more thing to look at when we're solving our equations. So let's look here what I've got. I don't want to complete the square because I don't have an x and a b term. All I have is an x squared term. So what I'm going to go ahead and do is just subtract 11 over to the other side. That's going to leave me with 2x squared equals negative 48. The reason I did that is because I'm noticing right off the bat that all I have is this x squared term, and I can get that by itself. So that's why I'm going to use this method of just using square roots. We'd have to divide by 2 to get it by itself, and I get x squared equals negative 24. You could have also used the quadratic formula to solve this if you wanted to. B would be 0. You just have to get your equation equal to 0 and then do A, B, and C. It's really whatever method you prefer. So now is where we're going to square root both sides. Your first instinct should say, oh, I see a negative, so I know I'm going to have an I in my answer. That's going to be true anytime you square root a negative number. If there's a negative under your radical, you're going to have an I, no matter what, when we're talking about square roots. So for this one, I know that 24 is 4 times 6. So we're square rooting that 4, and because it's negative, I get 2i, and I have the square root of 6. And so this is almost my answer because something that I forgot also is that, remember, anytime you introduce that radical to your equation, you have to have a plus or minus there. And I even left that off. So what we should have is x equals plus or minus 2i square root 6. This would be your final answer. Okay? It works exactly the same for solving as anything else, and you can use any method that you want to solve your equations. We have factoring, square roots, completing the square, or quadratic formula. Your choice. All right?